Partial differential equation. What is partial differential equation? An equation which is differentiable with respect to more than one independent variable is called partial differential equation. The process to differentiate partial differential equation is called partial differentiation or partial derivative. Partial derivative and partial differentiation is one thing. The word partial means to do something partially. Let's say if my function has f of x comma y. Now to differentiate this function, first it will be differentiated partially with respect to x and then with respect to y. That's what partial means. In the next lecture, I'm going to show you the first order partial differential equation, that how it looks like and how to solve a first order partial differential equation. Mathematical representation of partial differential equation. F of x comma y equals to x squared plus y to the 3. This is a typical partial differential equation. It's first order partial differential equation. The function f has two independent variables x and y. So it will be differentiated both with respect to x and with respect to y separately. Let me first differentiate f with respect to x to have partial f of partial x equals to 2x. Differentiation of f with respect to x equals to 2x. Differentiation of x squared is 2x. Ignore the y to the 3 term because there is no x variable. We deal with the x because the independent variable is x here. This is the sign of partial. Normally you will see partial f or partial x symbol, but sometimes you may have f sub x. This is one thing. Differentiation of f with respect to x, f sub x. Now differentiate f with respect to the second independent variable y, which equals to partial f of partial y equals to 3y squared. Differentiation of f with respect to y is 3y squared. Differentiation of y to the 3 is 3y squared. Ignore the x squared because there is no y variable. We deal with the y variable here. The independent variable is y. You may have sometime f sub y, partial differentiation of f with respect to y. Graphical representation of partial differential equation. Here is x-axis and this is y-axis. It is z-axis. Since it is partial differentiation, so the direction of the function can be at any side in 3D form. Can be ups and down, right, left, at any side. If my function has independent variable x and y, f of x comma y, the plane of the function is along x-axis and along y-axis. Now when I take my function and differentiate it first with respect to x, the direction will be along x-axis. And then when I differentiate it with respect to y, the direction of the function will be along y-axis. If you differentiate it with respect to z, the direction will be along z-axis. This is how a partial differential equation behaves when you draw it graphically. But when it comes to an ordinary differential equation, the direction of the function is only along x-axis or y-axis. Depends on the independent variable, because there is only one independent variable in ordinary differential equation. If the independent variable is x, it goes along x-axis. If it is y, it goes along y-axis. Let me compare ordinary and partial differential equation in the next lecture.